Hello, everybody. Welcome to probability beyond counting now. Now, instead of just saying how many ways are there to do this, now we're going to ask the question, what's the probability of this occurring? Let me get off screen so you don't have to look at my mug. Coming down to the end of it, everybody. My goodness, we're in June. Okay, so what is probability? Well, probability usually begins with an experiment. What is an experiment? It's just a situation that involves chance and leads to outcomes. What's an outcome? It's the result of any single trial of an experiment. What's an event? An event is one or more outcomes of an experiment, and the probability is how likely that event is. All right, so let's put all this to use here. What does all this mean? Let me keep the definitions right there. So let's just say you're at a carnival, which unfortunately would be happening right now in June if this were a normal year. The local carnivals of each town. So you might put money on a certain color or number, and then they spin. And this spinner has 4 equal sections: yellow, blue, green, and red. What's the chances of landing on blue? So the experiment is actually just spinning the spinner. Possible outcomes are blue, green, red, and yellow. The event being measured is being blue, and the probability of being blue is just one color out of 4, so 1/4. Done. In general, how do you find the probability of any event? It's just the number of ways that in any event E can occur. Let's just call the event E, and then you divide that by the total number of possibilities. So the event was blue, that's one total way. The total number of possible colors were 4, so that's just 1 out of 4. A probability will always be a decimal or fraction between 0 and 1. Okay, 0 meaning that it is impossible to occur, 1 meaning that it is absolutely certain to occur. So what if I say, what's the probability that February 30th will be on a Saturday next year? Don't be fooled. Is there a February 30th? No, there's never a February 30th. There's only 29 days in February, even on a leap year. The other 3 years, there's only 28 days in February. So there's a 0% chance that February 30th is on a Saturday. However, what if I say, hey, what's the probability that Thanksgiving will be on Thursday this year? That's a 100% chance. Or notice I say 100%. How do you write 100% as a number? 1. Okay, so a probability is always between 0 and 1. Okay, let's do a couple problems here. A box contains 12 blue, 5 black, 4 red, and 10 green pens. The first thing you need to do is add up all of the pens, and I do believe that adds up to 31 pens. That means my denominator will be 31 for all these. So what's the probability of being red? That's just 4 out of 31. What's the chances that it's blue? That's 12 out of 31. What's the chances that it's not yellow? Wait a second, are any of the pens even yellow? No. So all of the pens are not yellow. So that's just 31 out of 31. Not fooling me, Collodi. Or 1. What's the chances that it's not green? Well, if 10 of the 31 pens are green, that means 21 of the 31 pens are not green. And that's it. Okay. So let's get down to this right now. Reviewing some things you learned in middle school. All right, given the digits 1 through 9, so that means I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. That means my denominator for all of these is going to be 9. Okay, so what's the chances that it's odd? I often just like to write my possibilities. So that's 1, 3, 5, 7, and 9. That's 5 numbers out of 9. So then the probability of being even would be the other 4 numbers out of 9. Done with those already. Divisible by 4. So what does the word divisible mean? It means you could divide by 4 and have a whole number as an answer. So I know 4 divided by 4 is 1. I know that 8 divided by 4 is 2. So those are the 2 numbers in this group that are divisible by 4. So that's just 2 out of 9. It's a 9 right there. Prime. Oh, what are the primes? In case you have forgotten, a prime number is a number that's only divisible by 1 and itself. And the numbers need to be distinct. So the smallest prime number is actually 2. Mr. Cody, why isn't it 1? Because the 1 would be 1 times 1, and those numbers are not distinct. So what's the next prime number in this group? 3. 1 times 3. Next one is 5. Next one is 7. Is 9 a prime number? No, because 9 could be divided by 3 as well. So that's 4 numbers out of 9. Also, I'm going to share this with you right now. It'll be on today's assignment. Here's all the prime numbers between 1 and 100 that you can use. You may use this reference sheet at your disposal. Okay, so let's get back to the lesson. Okay, an even factor of 8. Factor, what is a factor again? A factor is a number that multiplies to give you that answer. So I know that 1 times 8 equals 8, and I know that 2 times 4 gives you 8. All right, so these are all factors of 8 and even factors of 8. So that means 1, you're out of here. So that means just 3 numbers remain. Mr. Cody, do we need to reduce? Yes, reduce. 1/3 is my reduced answer. A digit less than 3. Well, the other numbers less than 3 are 1 and 2. So that's 2 out of 9. And I'm done with that guy right there. Okay. When rolling a pair of dice, find the following. Okay, so when you roll a pair of dice, first off, how many outcomes are there? I'm going to go back to that reference sheet. When you roll a pair of dice, you have 36 possible outcomes. So here's the first die, 1, 2, 3, 4, 5, 6. Here's the second die, 1, 2, 3, 4, 5, 6. In here are all of the possible sums. If I roll a 1 and a 1, I get a sum of 2. Do you understand now? If I roll a 1 on the second die and a 2 on the first die, I get a sum of 3. If I roll a 4 and a 6, I roll a sum of 10, and so on and so forth. So let's go back to the question and see what it's asking. What's the probability that the sum is 12? I do believe that there's only one sum of 12 right here, and it's right there. Oops, there it is. That's the only sum of 12. So, cool beans, that's just one number. And by the way, how many total numbers are here? 6 times 6, there's 36 total numbers here. So I'm going to write that. When rolling a pair of dice, you have what's going on here? You have why am I not writing? 36 outcomes. So this is going to be 1 out of 36. What's the probability that the sum is 1? Wait, can I get a sum of 1? Even if I roll 2 dice and it's a 1 and a 1, that's a sum of 2. There's no way to roll a sum of 1. Not fooling me, Kalodi. The sum is an even number. I'm just going to cut right to the chase. On that 2 dice chart, half of the numbers are even, half of the numbers are odd. So that's 18 out of 36, which is 1/2. My advice, print out that sheet, that probability reference sheet, and use it to the best of your abilities. The sum is less than 5. Let's go to that reference sheet. Here's the great thing about this right here. And by the way, for each one, awesome thing, you could also just keep it like this, digital. Sum is less than 5. How many sums are less than 5? Aren't those the sums that are less than 5? So that's 1, 2, 3, 4, 5, 6 numbers that are less than 5. So that's 6 numbers. There are 6 numbers out of 36, which reduces to 1/6. The sum is an odd number. Again, half of the numbers are even, half are odd. So that's 18 out of 36 for 1/2. And then the sum is 4. How many 4s are there? Let's find out. All right, I can erase what I did here. How many 4s are there in general? These are the 4s. So all the particular sums are right there on the diagonal. So that's 1, 2, 3 numbers right there. So I'm going to write 3 numbers out of 36, and 3 over 36 reduces to 1/12. Done. Okay. Example 5 is exactly like the first example we did. I'm not going to go through that. What I will do is I will go through some problems that involve cards. And let me find one here. Okay. Here we go. Okay, given a full deck of cards, find the probability of drawing the 7 of spades. Some of you may not be familiar with cards, so there's where the probability reference sheet comes into play. Okay, so I go right down here. There are 52 cards in a deck. Half of those cards are red cards, and that's the diamonds. That's the worst diamond ever, and hearts. And half of the cards are black. That's the club, which kind of looks like, oh no, this is the spades right here, and then clubs. That's not bad, actually. Okay, so clubs and spades are black cards, diamonds and hearts are red cards. Then you split it in half again. Hearts and diamonds represent 13 and 13 cards, 13 clubs, 13 spades. When you break it down by suit, these are called 4 suits. There are number cards from 2 through 10. Then there are face cards, jacks, queens, and kings. And then there's an ace. An ace is not a number card. An ace is not a face card. So an ace is just an ace. So the 7 of spades, there's only one 7 of spades. It's right in there. So that's one card out of 52 total cards. 7 of spades, 1 out of 52. However, how many 7s in general are there? Well, there's the 7 of spades, 7 of hearts, 7 of diamonds, 7 of clubs. That's 4 cards out of 52. How many times does 4 go into 52? 13 times. A king, a queen, or a jack. There's 4 kings, there's 4 queens, and there's 4 jacks. Add them all up. That's 12 total cards out of 52. Divide by 4. 4 goes into 12 3 times. 4 goes into 52 13 times. 3 out of 13. What's the chances of drawing a heart? Use your reference sheet. Look at it. There are 13 hearts, so that's 13 out of 52, which reduces to 1/4. All right. And you know what? I think that's all I'm going to go over with you right now. I went through the reference sheet and I went through examples of each thing. Do your homework tonight. Ask questions if you have it. Bye.